All right, this is the notes for 5.4 compound inequalities. And in beginning to talk about compound inequalities, first we need to talk about what they are. Compound inequalities exist when we're taking a look at two inequalities together. So we're combining those two things. There are two types of compound inequalities. The first type is what's called an intersection. And in our notes, these would be using the word and. I'll explain this more. The second type is a union, and this uses the word or. All right, so for an intersection compound inequality, we know that this contains the word and. A intersection is true if both inequalities are true. Okay, and the graph is the overlap of the individual inequalities. So let me put this into words. If I was looking for a volunteer to do a project for the class, and this volunteer needs to be a boy with blonde hair, this would be an intersection. I'm looking for a boy and a boy with blonde hair, right? So both of those things have to be true in order to meet the requirements of my volunteer. Okay, that's a type of intersection. I'm looking for both of the two elements to be true. So if we take a look at an intersection, an example of this would be if we were asked to solve -2 less than or equal to x minus 3, which is less than 4. First thing with a compound inequality, you'll notice that we have multiple inequality symbols, and we know this is an and because it's all written together, or it's an intersection. Now let's go through the steps that we'll take to solve this inequality. One of the first things that I might do, it's really hard to see, one of the first things that I might do is to write with the word and. So I'm going to break this inequality apart. First would be -2 is less than or equal to x minus 3. And the second inequality would be x minus 3 is less than 4. Notice I've broken this one inequality into its two composites, or its two pieces. Now that I have it broken, I can solve each piece. Well, here, let's see, we would add 3 using the addition property of equality, and have 1 is less than or equal to x. Over here, notice it's the same thing, really. I'm adding 3, and I have x is less than 7. Okay. Now my last step is going to be to write the solution set and graph it. All right, so I typically will write my solution set before I graph it. So in set builder notation, my solution is the set of all numbers, my variables x, such that, and now here I'm thinking, how can I combine these two inequalities into one? Well, I notice that really, if you look at it, they line up pretty nicely. If I were to take see if I can do this. If I were to take this inequality, you can see those x's actually line up, right? So the set of all numbers x such that 1 is less than or equal to x, which is less than 7. That is my set builder notation. I've taken my two inequalities and put them together. Now, graphically, what this would look like if we graph the first one, and only the first one, we have 1, and it'd be a closed circle at 1. 1 is less than x. So 1 is less than x would be the same as x is greater than or equal to. So it'd be going this way. The second part of this inequality will be, there's 0, that's 0. I'm going to put 7 down here. 7 is going to be an open circle, I notice. Open circle, and x has to be, x has to be, I made that a closed circle. Let's fix that. There's 7, open circle, there we go. And then x is less than 7, so it's going to be all the values that are less than 7. Now, together, the intersection is the overlap. Where does this graph overlap? Well, it overlaps at 1 to 7. Here's the overlap. This is the graph of this compound inequality. All right. Give you an example to work on. We'll say -8 is greater than or equal to y minus 3. It's greater than or equal to -11. And I'll put 1b. 6 less than or equal to r plus 7 is less than 10. Go ahead and pause the video. Take a moment and solve those inequalities. Write the solution set. All right, solution set I came up with for this one would be the set of all numbers y such that -8 is less than or equal to y, which is less than or equal to -5. And here for 1b, we would have the set of all numbers r such that -1 is less than or equal to r, which is less than 3. If you did not get those, let me know. We can work on those.